Conversions are comparisons. So conversion factors are ratios. So remember, ratios can have a semicolon, but they also can have a fraction. So when we're doing our fraction, the top portion is our numerator, the bottom portion is our denominator. The ratio depicts an equivalent amount. So remember, we're trying to compare something, so we need to know what the equivalent amount is. Dimensional analysis is a process used to convert unit measurements. Okay, so there's a difference between the English measurement system versus the metric system. So predominantly, the English system is used in the United States. It typically consists of non-scientific measurements. So most of these should be very common to you. For example, 1 inch is equal to 2.54 centimeters. 12 inches are in 1 foot. 3 feet are in 1 yard. 1 pound equals 453.6 grams. 16 ounces equals 1 pound. 1 ounce equals 1,000 milligrams. And then we're getting into time. So 60 seconds are in a minute. 60 minutes are in an hour. There are 24 hours in a day and 365 days in a year. So with the metric system, it's typically used internationally. We have these things called SI units. So you should have become familiar with the SI units by now. So the way this diagram is set up, we have all the prefixes, we have the numerical values, and then their factors. So remember, this is all consistent with the basic unit here. The basic unit is going to be your grams, meters, or liters. Remember, grams are used as the unit for mass, meters are measured for distance, and liters are the unit used for volume. So the prefixes start with kilo. Kilo has a numerical value of 1,000. The factor is 10 to the third. Hecto, 100, 10 to the second. Deca is 10, and it's 10 to the first power. Then we jump down to deci, centi, and milli. Know that these are the inverse of the top three up here. So then we have 0.10 for deci, and that's 10 to the negative first power. Centi has 0.01, which is 10 to the negative second power. And then milli has 0.01, which is 10 to the negative third power. So when we do our conversion factors for our metric system, we're going to use our actual factors here, which have these numerical values. So we're going to start practicing conversions with our English metric system. So the question is, how many centimeters are in 1,908 feet? So in order to do this, you always start with what it gave you, which was 1,908 feet. So we set that up over 1, which is our placeholder. And then go back to the question. It's asking you how many centimeters. So you underline centimeters because we know that's what we want our answer in. So 1,908 feet, we need to get rid of this unit feet because we want our answers in centimeters. So the only way to do that is the equivalent value is feet or a foot. So in order to do that, we're going to put 1 foot as the denominator, and then we're going to use 12 inches as the ratio. So there are 12 inches in 1 foot. This cancels the feet here and the foot here. So now we need to get rid of inches just like we did with feet. So there are 2.54 centimeters in 1 inch. So that is what's going to be the equivalent value for centimeters to inches, and that's what's going to allow us to get rid of the unit inches. So now that we've done that, we're going to multiply across for the numerator and multiply across for the denominator. Then we would divide the two answers. So here, because the denominator is simply 1, whatever you multiply and get your answer for your numerator is your final answer. So note that we have our centimeters here, and it's the only unit that has not been canceled out so that we know that we're doing our problem correctly. So 1,908 times 12 times 2.54 will give you 58,154.84 inches. So it's 58,155.84 centimeters in 1,908 feet. So second question, how many grams are in 3.45, and if you can't see this decimal, that is a decimal, 3.45 pounds. So once again, this is what we're given, so we want to start with that, and this is what we want to answer in, which is grams. So 3.45 pounds is going to go at the top of our ratio. 1 is just our placeholder. So then we need to figure out, how do we get rid of pounds? Well, for every 1 pound, you have 453.6 grams. So pounds are going to cancel. We would multiply across, and that would be our final answer because it's just 1 is the denominator. So 3.45 times 453.6 grams gives you 1,564.92 grams. So that's how many grams are in 3.45 pounds. So now we're going to move on to our metric conversion practice. So this is when those factors come in, and remember, you can rewind the video to go back to determine what the numerical value is for each factor. So we have here, we're trying to figure out how many millimeters are in 56.3 centimeters. So this is what we're given, so we're going to start here. We have our placeholder value of 1, and then we need to get rid of centimeters. So for every 1 centimeter, you have 10 millimeters, which is 10 to the first power. So centimeters is going to cancel. Notice everything is a 1 in the denominator, so you just multiply across the top. 56.3 centimeters times 10 to the first power times 10 gives you 563 millimeters. So this is how many millimeters that are equivalent to 56.3 centimeters. Problem 2, we're given 356.8 milliliters. We want to know how many liters is that equivalent to. So we start with our given, our placeholder. We need to get rid of milliliters. So 1 milliliter is equivalent to 10 to the negative third liters. So milliliters is going to cancel. We'd multiply across. 356.8 times 10 to the negative third power gives us 0.3568 liters. The next question says, how many centimeters are in 0.673 meters? So this is what our given value is. This is what we want our answer in. We set up with our given. 0.673 is going to be over our placeholder of 1. Then you need to get rid of meters. So we're trying to figure out how many centimeters are in a meter. That's 10 to the second, which is 100. So meters is going to cancel. 0.673 times 10 to the second gives you 67.3 centimeters. Last problem for our metric measurements. How many kilograms are in 673.1 grams? So that's our given right here. And then we want our answer in kilograms. So 673.1 gram is going to be over our placeholder of 1. We need to get rid of grams. So we know that our equivalent amount is 10 to the negative third amount of grams. So grams is going to cancel. We're going to be left with our unit of kilograms. 673.1 times 10 to the negative 3, or the negative third power, is going to give you 0.6731 kilograms. Now it's time for some real-world application. So what we have here is an example of the English metric system versus the international or the metric system. So in the United States, we measure the speed limit by an amount of miles per hour. An example I gave you here is 60 miles per hour, or 60 mph, which literally means 60 miles per 1 hour. So in other countries, they measure the speed limit by an amount of kilometers per hour, so kmh. But what you need to know in order to do our problem is for every 1 mile, you have 0.621371 kilometers. So the question states how many kilometers per hour are in 60 miles per hour. So we're trying to find out how many kmh is equivalent to 60 mph. So we start with our given, which is 60 miles, and then we're going to put that over our placeholder value of 1. So we have 0.62137 kilometers divided by 1 mile. Miles will cancel. Then we're going to multiply across 60 times 0.621371 is going to give us 37.3, but you wouldn't drive that amount, so we will round that to 37 kmh. Two more problems of real-world application. And the next problem, how many light years are in 60 miles per hour? So with 1 year, you have one light year, is equivalent to 5.9 times 10 to the 12 miles. So 60 miles over 1 hour. We need to get rid of our hour here. So 1 hour has 60 minutes. So hours are going to cancel. Then we have, for every 60 minutes, we need to get rid of minutes. So 1 minute has 60 seconds. And light years are actually measured per second. So we're going to leave the unit seconds in. And then we need the light year because that's what we want our answer in as well. But every light year is equivalent to 5.9 times 10 to the 12th miles. So miles is finally going to cancel here. So we multiply across for our numerator, which would just be 60. And then multiply across for our denominator, which is 60 times 5.9 times 10 to the 12th power. So that's going to give us an answer of 9.3 times 10 to the 12th light years per second, per 1 second. So how many seconds are in 5 days for the next problem? This is something you're probably very familiar with. So we're going to start with our given, which is 5 days, and we want our answer in seconds. 5 days, and the only way to get rid of days is to have the unit of day. So days is going to cancel. We know that within 1 day there are 24 hours. So now we need to get rid of hours. So for every 1 hour there are 60 minutes. And then we know we want our answer in seconds, so we must continue. For every 1 minute there are 60 seconds. So we multiply across for the numerator and denominator. Here, denominator is just 1, so whatever you multiply across for your numerator is your answer. 5 times 24 times 60 times 60. You should get a final answer of 432,000 seconds. And after you keep practicing, this will become second nature, so good luck.